Hey, what's up? This is Mr. Luke. No, it's Coach Collins. But today is Tuesday, September 5th, and we are going to talk about families of foldable. No. Families of functions foldable. All right, let's get started. Actually, let's let Mr. Luke do this. Deuces.
All right, so let's get to that families of function foldable, okay? Now at this point, just remember you want to update your table of contents and remember to pause, and get that caught up. All right, now you got that updated. Let's look at the foldable. All right, so I'm assuming before you looked at this video, you grabbed the paper, but if not, and you have colored paper on hand, basically what you need is, let's see, all right, there it is. All right, so you basically need a piece of paper vertically cut in half, okay, and you need 5 of those in 5 different colors. Now, so I'm going to use, let's see, I got yellow, blue, purple, white, got another one of those, you don't need those, and I think salmon, is that the color? All right, so before I do that, I'm just going to kind of show you, this is what the end products kind of look like. Okay, so this is my last year's one. Okay, so that's kind of the end product. Okay, now at this point you might pause, go get a snack, take a deep breath because this is going to be a little longer video because it's going to take us some time to make the foldable. And then as you can see, there's a lot of notes going on. Okay, all right. So first things first, pick out your first color. I think I'm going to pick out white. Okay, and then you're going to put on top of that. Okay, just about, I don't know, it looks like about an inch apart. And then you're going to pick your next color and you're going to do that about an inch apart. And then you're going to do that about an inch apart. And again, since you're watching this video, if you're like me, like to be a perfectionist, you can take your time and measure and make it nice. But I don't want to let my perfectionism come out and like make a 40-minute video so it's like perfect. So it's going to be frustrating for me that mine isn't perfect, but it'll shorten your time in the video. All right, so then you have that. Okay, so all an inch apart. Okay, then you take it and then you fold it down and lost track of that. Let me try that again. All right, so you're gonna take it and fold it. There you go. It might take you a second to get that. Okay, and so basically you'll have it right when the one color overlaps there. So you can see the white and the white kind of overlap. Okay, all right, and then you're gonna crease this. Okay, and so what you'll have is something like this. Okay, so let me kind of go back over that. All right, so you have your paper, okay, and then you're gonna fold it, okay, so that see these little tabs, and so I'm gonna have to turn it. You're gonna fold it so that those fold down like that, okay. So you should have this, okay, and I think I can kind of show you like this better. So you see how these are the tabs. So you take those, and so there's no tabs on the side, and you fold it down, and then it's like that, okay? All right, and at that point, you want to find your blue stapler, and you're going to staple the top. All right, and if you did that right, you'll have a tab, a tab, a tab, a tab, and then again, the middle will have the same color. So tab, 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 tabby, tab, 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 tab. Okay. All right. So let's start with the title, and that is going to be the parent functions. All right. Now you're going to open that tab up, and underneath there, we're going to start with the first parent function, which is linear. Now you're going to want to probably write kind of small, or you might watch me write it all and then go back and fill it in so you kind of know. All right, so linear, let's start with the table. Okay, so X and Y. So I'm just going to give you some values. These values are the values of the linear parent function, or some of them. All right. Now, if it's linear from the table, we'll know because the first difference of each value is the same. So the difference between -2 and -1 is a +1. The difference between -1 and 0 is a +1. The difference between 0 and 1 is a +1. And the difference between 1 and 2 is a +1. We call this the first difference, in this case of the y values. So the first difference in the y values, if it's all the same, we know that it's linear. Okay. Now that's looking at it from a table. If you look at it from the graph, linear being line, okay, and if it's a parent function, okay, then it goes to the origin, okay. Now the domain is all real numbers, and the range is all real numbers. And the parent function is f of x equals x. All right, so this point, I'm only going to say it in this, but I'll do it in each one of them, but I'm going to pause for a second to give you a second to pause, and then you can make sure that you have all of that, okay? All right, so I assume you have that now. So now let's move on to the next function, quadratic. All right, so looking at it from again in the table, now the way you tell from a table if the function is a quadratic is the second difference of the y, okay? So the first difference between 4 and 1 is 3. First difference of 1 and 0 is 1. First difference of 0 and 1 is 1. And actually, almost made a mistake here, but it's actually -1. And this is +1. And then the difference here is 3, and that's a -3. So the difference between 4 and 1 is you subtract 3. The difference between 1 and 0, you subtract 1. And then from 0 to 1, you're adding 1, and 1 to 4, you're adding 3. Okay, so you'll see that the first difference aren't the same. So you know this isn't linear, so now we look at the second difference. Okay, so to go from -3 to -1, you add 2. To go from -1 to +1, you add 2. And to go from 1 to 3, you add 2. Okay, so this is the second difference of y. Now, again, mine isn't very neat, and I'm doing that kind of on purpose, not to drag out the minute. This is already going to be a longer video, but again, I don't want to make this a hour-long video. Okay, so what I recommend doing is watch me go over everything and then go back and then fill in the information so you can make it neat and tidy and neat. All right, so now let's look at graphically. And again, if it's the parent quadratic function, it's going to go through the origin. Okay, the domain is all real numbers. The range is y greater than or equal to 0. Okay, and the reason being is from left to right, the domain is continuous. Basically, these go on forever. But the range, it starts at 0, and then all the values are greater than. So thus, y is greater than or equal to 0. And then the parent function of the quadratic is f of x equals x squared. All right, now let's move on to cubic. All right. All right, so again, making a table. Now, I want to emphasize that as you're taking these notes, if there's something you have a question about, you might leave part of this blank and a little note yourself, ask Mr. Luke, say the cubic. Ask Mr. Luke to go over the cubic. And I can go over the cubic again and you can get some clarification, okay? All right, so again, let's look at the table. All right, now in cubic, to figure out if the table is cubic, you go to the third difference. So to get from -8 to -1, you add 7. To get from -1 to 0, you add 1. To get from 0 to 1, you add 1. And from 1 to 8, you add 7. Now you'll see the first difference is not the same. So we know it's not linear. So now we go to the second difference. So to go from 7 to 1 is you add 6. From 1 to 1, you don't add anything. You add 0. And then from 1 to 7, you add 6. Now you'll see that the second difference, the values aren't the same. So we know it's not quadratic. Okay, so now we look at the third difference. Well, to get from 6 to 0, it's 6, and from 0 to 6, it's 6. And actually, made a minor mistake here. To go from 7 to 1, you subtract 6. So to get from -6 to 0 is to add 6. And to get from 0 to 6, you add 6. So the third difference is the same. So because the third difference is the same in the y values, you know it's cubic. All right, so now let's look at the graph. Now this one you're going to want to have some tick marks, so just 2 here, 2 here. Here. All right. Again, for it to be a cubic parent function, it has to go through the origin. Okay. And we know from the table that 1, 1, negative 1, 1, and then -2, -8, which is about there, and then +2, +8. I don't know if I've told you this, but the tables we're using are the parent function table. Okay, so this is the parent function table of the cubic. But if it's a cubic, then it doesn't have to be the parent function values. If it works out in the third difference that they're the same, then we know it's a cubic. Okay. Now, from left to right, we know that this graph is continuous in both directions. So the domain is all real numbers. And then from bottom to top, it's going on forever. So the range is all real numbers. And then the function is f of x equals x cubed. All right, so finish that up. And now let's look at the next one. Let's look at exponential. Oh, no, I'm sorry. Yep, exponential. Now, if you're a parent out there, a student out there wondering, like, man, this video is long, crazy long, just know this is probably going to be the longest video of the year. And the reason is just there's so much content in this foldable, but the rest of it, it's really going to be some short notes and then some examples and probably 5 to 15-minute videos, okay? All right, so exponential. So we're looking at the table. -2, -1, 0, 1, 2, 0.25, 0.50, 1, 2, 4. All right. Now you'll notice that there really is no common difference, but there is a way to tell in the table if it's exponential, okay? And we'll talk about that right now, okay? And what we call those is common ratios. So if you want to know if from the table, if it's exponential, use common ratios, not ration, common ratios in y. Okay, so let's look at 0.50 divided by 0.25 is 2. Then 1 divided by 0.50 is 2. And 2 divided by 1 is 2. And 4 divided by 2 is 2. Since the common ratio of the y values is 2, basically the same number, it doesn't have to be 2, just the same number, then we know it's exponential. Okay? And then from the graph, now this one doesn't go in through the origin because it has an asymptote of y equals 0. Okay? And at this point or sometime before you come to class, look up asymptote, be prepared to tell the definition and explain it, okay? Now we know that it goes to 0, 1, so we just need that point. Again, we're just making the sketches. All right, so finish that one up. All right, now let's look at logarithmic. But oh, wait, almost forgot. We forgot something in exponential. We forgot the little pause there, see if you can figure that out. The function, which is f of x equals b to the x. Almost forgot that. All right, so logarithmic, okay? All right, so let's look at the table. So x, y, so 0 is undefined. One, 2, 4, 8. So 0, 1, 2, 3. All right. Now to know if from the table, if it's logarithmic, we use what's called common ratios of x. All right, so common ratios of x. So if we look at 8 divided by 4 is 2. 4 divided by 2 is 2. And 2 divided by 1 is 2. And we're not going to do the 1 divided by 0 because of the undefined. Now, something don't get distracted by. The common ratio doesn't have to be 2 in order for it to be logarithmic. It has to be the same value, okay? So the common ratio in x is the same value as in the ratios, then we know it's logarithmic, okay? Now, let's look at the graph. Now we know it's 1, 0, and it has x equals 0 as an asymptote. And again, that's a word you need to look up and be prepared to talk about when we come to class. Okay? All right. Now, the domain is x greater than or equal to 0. And the reason being is as an x asymptote, oh, actually not equal. Whoa, what was that? That was a bell. So I have a bellophobia. I'm afraid of bells. All right. Now, the reason why it doesn't have the line underneath because it doesn't include 0. But all the values to the right of this are the x value is greater than 0. Now, the range is all real numbers, okay? Because remember, from bottom to top, it keeps going in both directions, okay? And then the function is f of x equals log b of x. All right, now let's look at the next one. Let's look at cube root. All right, so let's look at the table. All right, and just thought about something, and that's not going to work. I need to actually move the table over here. Apologize for those of you racing. You're like, Arr! All right, so the values are -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. All right, now to know if it's cube root, we look at the third difference in x, okay, so in the x values. So to get from -8 to -1, you add 7. To get from -1 to 0, you add 1. To get from 0 to 1, you add 1. And from 1 to 8, you add 7. Now, this is the first difference, okay? So they're not the same, so we know it's not linear. So now we go, oh, actually, no, first difference, I'm sorry, whoa. We're talking about the x value. So really, we're only looking for cube root if we're looking at the difference in x's, okay? All right, so to get from 7 to 1, you subtract 6. To get from 1 to 1, you don't do anything. To get from 1 to 7, you add 6. Okay? And then, so it's not the second difference. So now let's look at the third difference. So -6 to 0 is you add 6. And to go from 0 to 6, you add 6. So the third difference in x is the same, so we know it's cube root. All right, so then to look at the graph, tick marks here, 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 and here. All right, so looking at the values, we know 0, 0. Almost all of the parent functions go through the origin with a few exceptions, okay? And so then we know -1, 1, negative 1, positive 1, 1, and then you can almost call this first tick mark 1 and 8, negative 1, negative 8, and so then here and here. So you have the cube root. All right, so for domain and range. All right, domain from left to right, it keeps going on in both directions without stopping, so it's all real numbers, and the same thing from bottom to top, so the domain and range are both all real numbers. All right, and then the function, the parent function of cube root is f of x equals cube root of x. All right. Now at this point, you're probably wondering, is there order or reason to the chaos in the colors? So you might think about that. Why the different colors? Why the order? Is there a reason why I'm going in certain order for these functions? Okay. All right. So the next one is whoa. Bells. They're so scary. All right. So now let's look at square roots. Let's see. All right. So what I did is I'm actually going to take this and fold it in half and make a crease. Okay. And so that way I have the table on top and then the graph below. Now you might think I'm crazy, by the way, for giving you a probably it's going to be a little over 30-minute video to watch at home. But this way, whoa! Bells again, they're so scary. Is this way you can take time to make it neat and organized as you want. Because if we did this in class, you're go, 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 and you're going to have to write kind of disorganized as mine. And these are notes you're going to want, and you're going to want to take the time to make them organized, okay? But again, I apologize for the length, but it's going to be the exception. It's probably the only video that's really long, okay? All right. So now, to know if it's square root, we look at the second difference in the x's. Okay, so to go from 0 to 1, you add 1. To go from 1 to 4, you add 3. To go from 4 to 9, you add 5. To go from 9 to 16, you add 7. So the first difference isn't the same, so let's go again. Okay, so you go from 1 to 3, you add 2. To go from 3 to 5, you add 2. To 5 to 7, add 2. So the second difference in x is the same. So we know it's square root, okay? All right. So now let's look at the graph. Okay, so 1, 4, 9, 16. What is taking out 4? 2, 3, 4. All right, so we know 0, 0. Again, almost all parent functions go through the origin, 0, 0, or touch the origin. Whoa, where are all these bells coming from? What is going on? All right, so 0, 0, 1, 1, 4, 2, and I'm getting these points from the table, okay? 9, 3, and 16, 4. All right, and then the domain, again, we go from left to right, so it starts at 0, and it includes 0, and it's greater, so the domain is x greater than or equal to 0. And range, again, we start in the bottom, so the bottom is 0 and it's greater than, so y greater than or equal to 0. And then the parent function of the square root is f of x equals the second root of x, also known as square root of x. All right, we're getting there, almost there. All right, so many functions, so many functions. All right, so now let's look at absolute value. All right, and then this one, what I recommend doing is drawing a line down the middle, because we're going to actually do absolute value and we're going to do rational. All right, so let's do absolute value first and then we'll do rational. All right, so for the absolute value, make a table, x and y. So -2, -1, 0, 1, 2, 2, 1, 0, 1, 2. Now, to note if it's an absolute value, we look at the first difference in y. So to go from 2 to 1, we add 1. From 1 to 0, we subtract 1. From 0 to 1, we add 1. And from 1 to 2, we add 1. Now, the first difference is the same, except for that -1. That -1 kind of interesting. Actually, if I'm actually accurate, from 2 to 1 is actually -1. Okay? Now, I can actually say, because they're the same numbers and the signs here are positive, these are negative, that the first difference in y is the same and that's because the definition of absolute value allows that. So at this point, you want to do some research and look up absolute value. Okay, and that will explain why +1, -1. But remember, if you look it up and you still have questions, that's a good point that we're going to go over that in class, okay? If you have questions about it. All right, the graph, again, touches the origin. All parent functions either touch or cross the origin, except for there's, I think, one exception. Here's your graph of the absolute value. All right, and domain is all real numbers because, again, from left to right, there's no stop. They keep going in both directions. And then the range start at 0 and it's greater than, so y greater than or equal to 0. And it's equal to because it includes 0. And then the function is f of x equals the absolute value of x. All right, so now let's look at the rational. All right, so table x and y. -2, -1, 0, 1, 2, -0.5. Excuse me. This is Coach Odin, and I really need to answer that. Yes, sir. Yes, I got that. Yeah, what time do you think you're gonna be over in the building? Um, yeah, I can drop it off at the field house. Yeah, I got the calendar, I got all the materials. I'll get I'll get that to you. Is the scrimmage over or no? Okay. All right. Well, let me finish some stuff I'm doing, and I'll come by and drop it off. All right, no problem. That if you got athletes, that's Coach Odin. I gotta get him some materials, get him set, and we gotta take care of the coaches because they care about our Wildcats. Okay, they do a lot of work for our Wildcats. Okay, so if you ever see a coach, thank a coach. They do phenomenal work, and lots of work. All right, so -1, undefined, 1, 0.5. All right, so then graph. And we know that because from the table, 1, 1 and -1, 1. And that's on a rational function, that's really the only point you really can graph is just those points. You need the points to know where the curves are, okay? All right, so domain is all our numbers again because it keeps going in both directions, but it doesn't include 0. The graph never crosses or touches x equals 0. Okay, and then the range is all our numbers. Y does not equal 0. Okay, and again, because it doesn't cross at y equals 0. All right, and then the rational parent function is f of x equals 1 divided by x. Please do not say over. This is not a correct mathematical term. It's 1. This is the division symbol. 1 divided by x. All right, almost there. Last thing. All right, now the last thing is inverse functions. All right, and at this point, you're probably like, Mr. Luke, come on, Mr. Luke, this video is too long. I know, I'm making it long video, but it just so happens I have a copy of mine from last year, and so this one you really don't need to. The others you had to see kind of how it was going, but this one I think we can just kind of go over it. So this is the last one. Now you notice I just went from purple to green because last year's green, this is purple, but this is the last thing. All right, to find an inverse, f inverse of x, we have 1. Its graphical reflect over the y equals x line, f of x equals x, or to test for an inverse, you do a horizontal line test, okay? Now, the algebraic way to find an inverse is switch the x and y and resolve for y, or use composition of functions to determine the inverse, where the f of f inverse of x is equal to x and m inverse of f of x equals x. So if you get x's for both compositions, then they're inverses. And another note, if they're inverses, the domain and range will flip. Okay, so let me just go back. See here, let's go back here. Pause for a minute. So if you need to get anything from that, all right, it's been paused. And then you're gonna have to write algebraic because it's about to get cut off. And then here. All right, Wildcats. This is concluding the video. And again, wow, 40-minute video. Thank you for watching. And be ready to, I'll be able to answer any questions and we can get kind of a jump start on things. And again, if you're a parent watching this and like, my parent, you just had them watch a 40-minute video. I'm a parent. I know, but this is like, this is a lot of information, and I assure you, this is probably the one and only longest video. And if you want to look, I have all my videos from last year up on YouTube, so you can kind of scan and you can see the length on those. But I will leave you with one thing. There's a color. I want you to come to class and talk to me. What connection does the color have? Okay, there's a significant connection, and if you can figure out that, you're pretty Wildcat smart. So with that, have a wonderful Wildcat evening.